Welcome students. Today our lesson is over Notes 3.2, Use Parallel Lines and Transversals. In a previous lesson we learned about the different types of angle relationships, so we're just going to review the vocabulary a little bit here. If you'll refer over here to this picture, you will see that you have two lines, line X and line Y, which are both being cut by this transversal. Remember, a transversal is a line that intersects two or more lines. When you do that, it's creating 1, 2, 3, 4, 5, 6, 7, 8 angles. And when we're talking about corresponding angles, we are talking about angles that are on the same side of the transversal, but one is going to be inside and one's going to be outside. So here, remember, when I'm talking about inside and outside, we think about this as a sandwich, and this is the toothpick. And this is going to be the outside of the sandwich. And the orange area, this is going to be the interior of the sandwich. Okay? So the yellow is the exterior, the orange is the interior. And so when we're talking about corresponding angles, we're talking about 1 and 7. So angle 1 and angle 7. We're also talking about 2 and 8. Oops, angle 2 and angle 8. We're talking about 4, which is an exterior, and 5, so angle 4 and angle 5. And then finally 3 and 6, angle 3 and angle 6. Okay? Alternate interior angles, those are interior. Those are going to be only the ones inside. So alternate is going to be on opposite sides of the transversal. So that's going to be angle 1 and angle 6. And then there's also angle 2 and angle 5. The next one is alternate exterior, exterior being yellow. Okay, so we're talking about alternate, so that's opposite sides of the transversal. So that's going to be 3 and 7. And then we also have 4 and angle 8. Okay. Consecutive interior, again, we're talking about interior angles only, so that's only the ones in orange area. And consecutive means on the same side of the transversal. So this being the transversal, same side, that's going to be 1 and 5. And then finally, angle 2 and 6. Okay, so now what we're going to do is we are going to pause, and I want you to go get a protractor, and I want you to use your straight edge, and I want you to extend these lines, and I'll give you just a minute to do that. Alright, now the reason I needed to extend these lines is when I go to measure these angles, if I don't have the lines extended, I'm not going to be able to use my protractor effectively. So in order to measure each one of the angles, I need to locate the angle. This orange angle right here, that's angle 1. So I'm going to put this point on the protractor right here at that vertex, and you'll see that there's a line right here. You're going to line that line up with the transversal. So right there, it lines up. Okay, and so I'm going to put my pencil there and I'm going to rotate it around. Here, you've got to make sure that this line right here is lined up with the transversal as well. So if you think about angle 1 is starting over here and then it's opening up this way. So since it starts over here and opens up this way, we're going to use these top numbers. So here, if you measure, it's going to measure out to here. That's going to be approximately, looks like about 85. So if you look, here's your 80, here's your 90. So that's about 85. Or it could be between 90 and 100 or 95. So there's two numbers there. So is that, you have to look at the angle. Is it acute or is it obtuse? So since this is acute, this over here would be 85 degrees. Okay, and then you do the same thing for angle 2. So here's angle 2. So we're going to put our vertex here. We're going to line it up. And this time, it's going to open up this direction over here. So I'll move this over so you can see. So it's going to go this direction. So over here, and if you follow that out, that's going to be, here's the 90 degree. So it's going to be 95. So angle 2 is 95. And then you just keep repeating that. So angle 3, if you look at angle 3, it's going to open up over here and go around. That's going to be at 85. And angle 4 is going to be over here. It's going to open up and go this direction. So there's 90, so it's going to be at 95. Now that should make sense to you because 1 and 3 should be equal. And then 2 and 4, those should be equal as well because those are vertical angles. All right, next let's measure angle 5. I'm going to measure angle 5. Angle 5 is about 70, there's 70 right there, so 72. So when I measure it, I get 72 degrees. Okay, and then angle 6 is right above here, so those are called vertical angles. So angle 6 should match angle 7, and then 5 and 8 should match. Since we know 5 is 72, we know 8 is going to be 72. And then we also know that this is a linear pair, so we can subtract for 180. But if we go ahead and measure and just practice our measuring skills, then we know that it's going to open up over here and go all the way around. So that's going to be the small 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 108. So that looks like it should be 108 degrees. And so this one should be the same. Now, the way you double check it is you look for the linear pair. So 1 and 2, angles 1 and 2, when you add those together, that should be 180. And then 5 and 6, when you add those together, you should get 180 because that's a linear pair. All right, so that's it for our vocabulary review and our review on how to use a protractor to measure our angles. Now let's go ahead and finish here. Let's take a look down here. Now look what happens. Use the diagram below. List the following angles according to their angle pair relationships. Well, what's the difference between this picture and this picture? Take a look at line X and Y, and take a look at lines M and N. As you can see, these two lines intersect. These are not parallel. But if I stretch these out, these are parallel. And you know that they're parallel because you see this symbol right here. Whenever you see a symbol on a line like this, or it could be a double, like this, that means that the two lines are parallel. Okay, so again, list the corresponding angles, one inside, one out, and you can go ahead and shade them. This is out, these are exterior, these are interior. So this time, notice how they're numbered a little bit different, so don't think that you're just going to go up here and write the same information down here, because these are numbered differently. So corresponding, that's going to be angle 1 and one inside, one out. So angle 1 and angle 3. Angle 2 and angle 4. 2 and 4. 5 and 7. And finally, angle 6 and 8. Those are all the corresponding angles. Next, we have alternate interior. So 2 and 7, 3 and 6. Angle 2 and angle 7. Angle 3 and angle 6. Then the exterior, and you can even color code these as well. So remember, interior is the orange. There's orange down here. And then exterior. Okay. So the exterior, that's going to be 1 and 8. 4 and 5. Okay, and then consecutive interior, same side. Interior, 2 and 3. 6 and 7. Okay, now this time I'm going to stretch out. Make sure that you get it precise, because it'll be a little bit off. If your measures up here were a little bit different than mine, that just means that when you traced over the line, you didn't trace it carefully to make sure that when you stretched out the lines, that they were actually the same lines. Go ahead and stretch out the transversal. There we go. Okay, and now go ahead and measure. When I measure, line it up. When I measure all the way around, I get, to me, that looks like 108. So angle 1 should be 108 degrees. Angle 2 is this acute angle down here, so I'm going to measure that one, line it up. So when I go around, there's 0 here. It's going to open up to here. That looks like 72. So this one's 72. And notice how those are linear pairs, so when you add them together, it should be 108. And you can use your vertical angles to save some time. So 1 should be like 6, so that's 108. And 2 and 5 should be the same, so that's going to be 72. All right, now measure the ones down here. So for the second line, we're talking about line in now. You're going to line this up, and you're going to measure angle 3. So it goes around, start here with 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and 8. So 3 is 108, and 3 matches 8. So over here, this should be 108. And then again, when you line this up, it starts over here, 0, 10, 20, 30, 40, 50, 60, 70, 172. So this should be 72, that's angle 7, which matches angle 4. Okay. Alright, so there, it says, what do you notice? Well, up here, we notice that these measurements were 85 and 95, and down here, these measurements were 72 and 108. Over here, these lines are parallel. These measures are 72 and 108, and these measures are 72 and 108. So what you should notice is that the corresponding, let's see, so my angle 1 and my angle 3, those are corresponding. My corresponding angles are congruent. I'll use the symbol congruent. Let's check out our alternate interior. 2 and 7. Well, 2 and 7 are the same. So my alternate interior are congruent. Now let's look at our alternate exterior. My alternate exterior 1 and 8, angle 1 and angle 8, those are the same. So alternate exterior angles are congruent. And then finally, consecutive interior. Consecutive interior, that's angle 2 and angle 3. So angle 2 and angle 3, those are not congruent. But they do have a relationship, 72 and 108. 72 and 108, when you add them together, that's 180. When you add them together and they equal 180, we call those supplementary. So here, we know that our consecutive interior angles are supplementary. Okay, but that only happens, this information right here only happens when the lines are parallel. All right, let's flip it over to the back. And that leads us into how we discovered postulates and theorems. So right here, the corresponding angles postulate says that if two parallel lines, so here's the important information right here, the two parallel lines, see these lines right here are parallel, okay, if they're cut by transversal, then the pairs of corresponding angles are congruent. So, in summary, what this means is if M is parallel to N, then angle 5 is congruent to angle 7. Okay, next, alternate interiors. Alternate interior angles theorem. If two parallel lines, here's that word parallel lines again, parallel, are cut by transversal, then the pairs of alternate interior angles are congruent. Okay, so when you summarize this, you say if M is parallel to N, and that's the symbol for parallel, then angle 3 and angle 6, those are congruent. And of course there's another pair, but we just chose one of them. Okay, now we have alternate exterior. So F2 parallel lines, there it is again, parallel. If two parallel lines are cut by transversal, then the pairs of alternate interior angles, oops, that's a typo right there, so you need to fix that. So the pairs of alternate, that should say exterior angles are congruent. So that's going to be if M is parallel to N, comma, then alternate exterior, that's going to be angle 1, is congruent to angle 8. So 1 and 8. And finally, consecutive interior angles theorem. If two lines are parallel, there it is again, parallel, are cut by transversal, then the pairs of consecutive interior angles are supplementary. So the measure of, line M parallel to line N, if those are parallel, then we can say 6 and 7, angle 6 and angle 7 are supplementary. Okay, I want you to take a minute and think about these. You have to think about what kind of angles am I given. First of all, these are interior. I used orange for interior. They're on opposite sides of the transversal. There's my transversal. I know that these, here's the parallel symbols. I know that these lines are parallel. So that means that these are alternate interior. That's this up here, alternate interior. Okay, so that means that they are congruent. So I know that when things are congruent, I know that this angle is congruent to this one. That means that the measures are the same. So I can say, write the equation, 3x is equal to 84. Divide by 3 on both sides. Divide by 3, divide by 3. That means x is equal to 28. So let's write the equation to solve for x. Identify the theorem for each. This theorem was the alternate interior angles theorem. All right, next. Take a look at, do I have parallel lines? I do because of this symbol right here. It's cut by this transversal. There's my inside. That's the interior. Here's the exterior. When you have one interior and one exterior on the same side of the transversal, that's corresponding angles. So I look up here, corresponding angles, postulate. So that's not a theorem, that's a postulate. Okay, so this is going to be corresponding angles, postulate. Okay, and so that tells us that when these are parallel, cut by this transversal, that these are congruent. That means that their measures are equal. So for an equation, we set these two equal to each other. That's going to be 14x plus 9 equals 5x plus 90. And then we use our algebra to solve, subtracting 5x from both sides of the equation. I am left with 9x plus 9 on the left equaling 90 on the right. Now subtracting 9 from both sides, I'm left with 9x on the left equaling 81 on the right. Finally, divide both sides by 9. I get x equals 9. So I found my x. Here's my equation that I set up to solve. Found my x, and there's my postulate that I used to find it. All right, folks, that is it for notes 3.2.